Cool. So we're looking at the Plix, Plix, that was underneath the triangles I was moving around that were reflected. And this is just another animated, or at least pull out thing that you can look at and use. All right. And I'm just going to walk through it. So it's telling me transformations are a way to indicate the movement of geometric figures. It's just good to read it here out loud. Move the red point in order to change the shape of the blue geometric figure that is reflected, and the reflected red geometric figure. So here's the red points moving the blue figure. It's going to move that guy. Let's take a look. Yeah, all right, just like we saw before with that other one. Cool. So let's go ahead and do a challenge. What type of transformation is this? Is this a translation? Well, again, a translation slides something, all right? And even though I'm sliding these points, theoretically, I'm not sliding my whole shape, so that's not correct. A rotation, does it look like this guy's rotating as I move it? Not really. Everything other point is staying exactly at the same spot, so that can't be it. A reflection, I think it's a reflection. I mean, look at this y-axis. It's almost like it's a perfect mirror for this guy. And as I get closer to the y-axis, bam. Hey, notice where those guys intersect? You can see that's actually where that line of reflection is going to be. All right, so when you see the two shapes sharing a point, that's a very good indicator that the line of reflection goes through that point. Cool. I'm going to go ahead and do reflection. All right, dilation would just make it bigger and smaller. All right, that's not what's going on here either. So submit. Excellent. Let's go on to challenge question 2. If you form a geometric figure by placing the red points on 5, 5, all right, so let's go ahead. The red points on 5, 5. Cool. 5, negative 5. Okay. 5, negative 5. Ooh, this is starting to look interesting. All right. Negative 5, 5. This guy's going to be brought over here. And then negative 5, negative 5. What? All right. The reflected shape will look exactly the same as the created shape. Hey, look at this. These 5s are kind of the hint to the answer on this one. We can clearly see that this is going to be true, all right, because we've overlapped them entirely. But if you notice too, this is kind of the cute thing. It's 5 away from the line of, the reflection line. And actually, in this case, it could be either one of these, all right? We find out when we do that, but at this point, we don't know. So since they're all the same distance from either one of these 5, then you can kind of know that when they'll overlap with each other. Cool. The red geometric figure is reflected version of the blue geometric figure across which line? So let's get our guys back together, all right, just so we can kind of see this a little more clearer, all right? So the red geometric figure is the related version of the blue geometric figure across which line? Looks like it's going to be the y-axis, all right? Nice. And then the last one is just an open discussion. Can you think of any geometric figures that will look exactly the same whether you reflect the shape across the x-axis or y-axis? And I kind of talked a little bit about this already, so if you're able to give me a good written answer, show it to me in class or show the checker, they'll give you 3 zeta for that, all right? So that's like an extra credit. Discuss this with others. And there we go. We've finished our Plix challenge. All right, hopefully just seeing this thing, opening it up, taking a look at it, showing you how it works will help you use it and also use future ones. All right, awesome. Take care, guys.